Thank you, Kavisha. Hi, everybody. Kubernetes is a unique beast which consists of a multi-layered web of resources and services. Achieving observability is a daunting task, even for the best and brightest among us. This presentation will give you a high-level overview and some implementation approaches to achieve observability in Kubernetes. So let's first look into what is observability. To understand observability, the observability as well as monitoring is used interchangeably, although there's a subtle difference between them. While observability actually talks about the ability of internal to assess the internal system state based on the data it provides, monitoring deals with the collection and analysis of data pulled from the infrastructure. So observability will help you to gain deeper insight to health and status of different applications and resources across infrastructure. This helps to proactively detect abnormalities, analyze issues and resolve them. So the three pillars of observability are logs, metrics and traces. I will discuss that in later. Let's move into the monitoring. So the foundation of observability is monitoring, which involves pulling and analyzing data from your infrastructure. So it started with SNMP, the simple network protocol, since back in 1988, where we used to get information about the network, say for example like every 10 seconds or 30 seconds. Now there are much more newer protocols available, such as the OpenConfig, gRPC network management interface protocol, that can provide much more real-time information. Okay, telemetry and APM, application performance monitoring, also a type of monitoring. It's a bit advanced type of monitoring. Especially telemetry focuses on collecting information from distributed system, while the APM is focuses on more application level. Let's look at what are the different types of levels of Kubernetes monitoring. So there are two types of Kubernetes monitoring available, two levels of Kubernetes monitoring available. One is the cluster level, which focuses on the node information, the pod information and the cluster resource level utilization. And the pod level focuses more on the container level, especially on the application as well as the container level information. Okay, let's see why this monitoring is so important. So in cloud native or microservices, apps are very complex and you got a lot of moving parts. When an issue occurs, it's very difficult to pinpoint and identify the issue. So monitoring is important for reliability as well as troubleshooting. Secondly, knowing your infrastructure will help you to optimize your hardware. Thirdly, public cloud, if you are using a public cloud infrastructure, you will play the cost will play a major role. So having insights into the Kubernetes environment will help you to reduce the cloud spending. Some instances you may be using Kubernetes in a multi-tenanted, or you are providing it to your internal customers. So in that case, having insights will help you to charge back or show back to your internal customers. Finally, observability is actually a cornerstone for your security strategy. So you will be able to identify any malicious ingress and egress traffic or any unwanted pods and services that is running in your environment. Alright, so there are some challenges that comes through with this observability as well. So one is the amount of data. So you get data from your nodes, you get data from your pods, the flow data, so much of data that you have to manage. And secondly, you also have difficulty because it's a distributed system. You have so many moving parts. Getting this full picture also is a bit of a challenge that you will face as well. Finally, you will, because Kubernetes is a declarative in nature, you can actually define how you want the pods to run and created. So that actually might give a false positive, especially when it comes to performance. Alright, so the best practices. When it comes to best practices, firstly, the granular resources like the CPU, memory, load, those things are very important, but can be very complex and convoluted. So to easily identify the microservices issue, the API metrics are the main part. So what you can use is like the request rate, the call error, latency. That will help you to quickly identify the degrading components in your microservice. Another aspect is the high disk usage. So that's a very common issue that you will come across. So there's no like a straight away magical solution. You just make sure, you know, when it hits about 70 to 80% of your storage, notify it, take some actions, right? So even though the user experience, end user experience is not built into Kubernetes, it's also very important and a best practice to understand and monitor end users experience and address issues so that the end user can provide you positive feedback as well. And if you are running in public cloud, you have to make sure you adhere to the best practices of the cloud in terms of access and identity, cost, network performance, etc. Alright, let's get back to the 3 pillars of observability. As I mentioned, it's very important when you create and implement your observability for Kubernetes. So for the first pillar is the logs. The log, basically a log is a representation of a discrete event. In most cases it describes what will happen with your service. Log will produce in multiple ways in Kubernetes especially. So you will have cluster related log, you will have pod related logs, you will have application related logs, network and all that. So you have to have a mechanism to collect all these logs and push it to a central analytic server. Second pillar is the metrics. So metrics is a numerical representation of data measured over a period of time. Say for example, how many 200 requests did I get in last 30 seconds? And the last one is the tracing. Tracing is a mechanism that will help you to track end to end and identify. So your whole transaction you can manage you can track it end to end and identify, troubleshoot the issue. Alright, so let's look at a sample of purpose-built observability platform for Kubernetes. So this one, we have 3 layers. So the first layer is the telemetry collection. So this is where you collect various flows and different data. And the second layer will give you the analytic and visibility, where the different analysis can be performed. So you could even put some machine learn anomaly detection, and finally on the security and troubleshooting layer. Tools for implementing Kubernetes observability includes, first, at the bare minimum, you can have Kubernetes dashboard. Kubernetes dashboard will give you a bare minimum information about the deployment of application into pods, application running in pods, issues with application running in the pods, resource utilization. So this can be used as a bare minimum observability tool. Secondly, Prometheus is a collection and storage of observability data. So it provides you with a multi-dimensional data model with time series format, and it also provides a query language called FromQL to analyze. Further, several modes can be are available with different type of graphs as well as dashboards. Prometheus can be integrated with many things like the Grafana and all that as well. So on Grafana side, it will give you a visualizing observability data. So Grafana gives you a data rich dashboard and using information sources like the Prometheus, like I just mentioned. And it also provides you built-in dashboards for Kubernetes, like actually 4 dashboards. One is the cluster dashboard, node dashboard, pod and container dashboard, as well as the deployment dashboard. Further, Grafana has a few more plugins that, for example, Grafana Loki also can give you a similar observability to your Kubernetes environment. And Jaeger is a distributed system tracing system for Kubernetes. They actually came from Uber's engineering team. It gives you end-to-end tracing solution. So it helps you to monitor, troubleshoot transactions in a complex distributed system and help you to identify the root causes as well as optimize performance and latencies and monitor distributed transactions as well. further. Finally, the Elastic Stack. Elastic Stack includes Elasticsearch, which is the analytical engine, and Logstash and Beats captures and sends the log to Elasticsearch, and Kibana, you can use it to get the dashboards. You can also drop Logstash and Beats and combine it with something like a Fluent, then you get a EFK stack, which also will give you a stack for you to implement your observability in Kubernetes. With that, because of the scale of modern infrastructure and the dynamic nature of Kubernetes, observability is a critical component. And the three pillars I mentioned you, that is the log, metrics, tracing, will not only help you to increase the observability, but also help you to gain insights to your infrastructure, regardless of your technology stack that you use. The tools mentioned here are the de facto standard tools used by the cloud native community, and implementing them will help you to gain observability in your Kubernetes environment. Thank you and have a pleasant day.